Alrighty, here we go. So now we are looking at Charles' law. Charles' law is going to relate volume and temperature initially and volume and temperature final. So it's always going to be, oh, this should say volume. There it is. So you always have to make sure that you are working with Kelvin when it comes with temperature. All right, so let's get started with the problem. My first step is going to be writing down my formula. So V1 over T1 is equal to V2 over T2. Next step, identify my given variables. Again, I am only going to be given volume and temperature. So I'm going to have to find V1 T1 and V2 T2 in this problem. All right, let's start with that. A sample of gas is held at 132 degrees Celsius at a volume of 13 liters. This sounds like my initial values of volume and temperature. So volume is 13 liters. Temperature is 132 degrees Celsius. However, you have to remember that for temperature, we always have to work with Kelvin. So you have to do the degrees Celsius to Kelvin conversion. All you're doing is just adding 273 to whatever Celsius value you have, and you will have, sorry about that, you will have the Kelvin equivalent. So 132 plus 273 is 405. 405 Kelvin. So I got my initial values. Now let me find the rest. If the volume is increased to 26 liters, what is the new temperature of the gas in Celsius? So they want me to find the new temperature, the final temperature, T2. So now I can go and plug in my known variables. V1 is 13 over T1 is 405 is equal to V2 is 26 and T2 is unknown, so I'm just going to leave it as T2. You can substitute that as an X, whatever variable letter you want. So now I'm going to cross multiply. So 405 times 26 is equal to 13 times T2, 13 T2. I want to solve for T2, so I'm going to divide both sides by 13. And now I have that T2 is equal to 405 times 26 divided by 13. That's 810. So T2 is equal to 810. Remember, T2 is your temperature, and temperature is in Kelvin. So that is your final temperature. However, the question is asking you what is the new temperature of the gas in Celsius. So I have to convert Kelvin back into degrees Celsius. And I do that with the same equation. So my equation, I will start up here, is degrees Celsius plus 273 is equal to Kelvin. I am trying to solve for degrees Celsius, I don't know that yet, plus 273 is equal to, my Kelvin value is 810. All I have left to do to have degrees Celsius is just subtract 273 from both sides. So 810 minus 273 is 537. So degrees Celsius is equal to 537. So my final answer is 537 degrees Celsius.